Hello guys, welcome to my YouTube channel. This is Sichamba Jacob. Alright, so we've got this question right over here. We need to integrate f of x comma y is equal to x over y over the region R bounded by x is equal to 1, x is equal to 2, y is equal to 1, and y is equal to x squared. So to be able to answer this question, we need to identify the region. That's the first thing, identify the region. So for the region to be identified, we shall graph these equations, okay? So we'll start with this one. It will move like this. It's a quadratic equation, and the turning point is at the origin, okay? And then after that, we come to this one. It will be right here, okay? That is x is equal to 1. It's passing at 1 on the x-axis. Remember, this is x-axis and this is y-axis. So we can say this is x is equal to 1, while this graph is y is equal to x power 2. And then we can come to this one, which will, of course, pass somewhere here. They will meet here. So this is y is equal to 1 because it's passing at 1 here, okay? And lastly, we do this one. So it will pass like this. If this is 1, of course 2 may be somewhere here. So this is a 2. X is equal to a 2. It's passing at 2. So we've done all the 4 equations, 1, 2, 3, and 4. So where this region we're talking about is, it's somewhere here. This is where the region is. Because this region is bounded by this equation, and this equation, okay? We can't pick this because we don't have an equation down here. We can't pick this. We don't have an equation up. We can't pick any other. We only pick this region as our R where all these equations are bounded, okay? So after knowing the equations, it's important that you know the coordinates. So here, where they're meeting, the meeting points, here and here. So there are 3 meeting points. So of course, for this one, we can say it's a 2, 1. So this one is a 2, 1. So this is 2, 1. This one is 1, 1. You can see this is 1, 1. But for this one, we know, of course, the x-axis at this point, it's a 2, the y-axis we don't know. So we're going to get this equation, which is a y is equal to x power 2. And then we substitute the y value at this point, which is the x value, which is a 2. So it will be y is equal to 2 power 2, which will give us a 4. So 2 power 2 is giving us a 4. And this is the 4. So it's 2, 4. Okay. So now, after we've done all these things, we can now bring in the integrals. So double integral. Okay. The lower limit here will be a 1. Okay. So you start moving, okay, going upwards. Okay, let me do this. Let me move along the x-axis. So we'll be moving in this direction. So we're moving from here to here. Before we reach this region, the first equation that we're touching, it's a y is equal to x power 2. Now that we are moving in the x direction like this, we are supposed to make x subject of the formula. So it will be square root both sides. So we shall have root over y. Okay, that's root of y is equal to x. Root of y is equal to x. So now we know that we are touching the x is equal to root of y first, and then lastly, when leaving that region, we touch the x is equal to 2. Therefore, we can say this is the lower limit. The upper limit will be this line over here, which is a 2. And then for the outer integral, it will be going along the y-axis. So the first equation that we're touching, it's a 1. Y is equal to 1. Next, after we move like this, we're touching this other equation. But we are not going to get the equations. We'll get the points along the y-axis. So the first equation, the y-axis here is what? It's a 1. And then we come to where they've met here. The y-axis here is what? It's a 4, the 4 we found here. So this is the 4. And this is the integral we need to work with, the double integral we need to work with. So we shall say what they've given us here, that is x over y. That's what they've given us, and it's what we're trying to integrate. So first, we moved along the x-axis. So we shall say dx, because we are moving in this direction, and then lastly, we come and move in along the y-axis. So it will be dy, like that, okay? So now we just integrate this. This will be the integral. I mean, the lower limit there is 1, upper limit is a 4. In this case, we are respecting x, so we're going to integrate this x. The y will be treated as a constant. So this will be x power 2 over a 2 and the y down here. So let me just show you what I've just done here. There is x, okay, which is this one. So when integrating, there's a power 1, we always add a 1, okay? So 1 plus 1, it will give us a 2. And then we say over the same thing, okay? Over 1 plus 1. And this will give us x power 2 over a 2, okay? There is already this denominator, which is treated as a constant. So it won't go anywhere. It will maintain the same position. That's why we've got a 2y down here. And after we've done this, we can now write the limits right over here. The lower limit, it's a square root of y. The upper limit, it's a 2. We've remained with a dy, okay? So now from here, we of course can say, from here we can apply or plug in the limits. So when we write the limits, the upper limit, it's a 2, so it will be 4 over 2y. I know you may be wondering that why are we having this 4? So when we substitute a 2 here, where x is, we're going to have a 2 power 2, which will give us a 4. So just here on top, we have a 4 over the denominator, which is 4 over 2y. And then we say minus, we shall say minus. The lower limit, when we substitute, we shall have y over a 2y. So this is what we're having here, and then we say dy. Again, on the same, we get this, put it where x is. Here, there's a power 2. So this and this will go, we remain with a y. On top, we remain with a y, which is this one right here. Okay. So now from here, we can say, or we can clean up. The integral limits from 1 to 4. And then we've got 2 over a y. This is because 2 into 4, it's a 2. Into 2, it's a 1. So this is what we're going to remain with. Then we say minus. Here it will be 1 over a 2 dy. Y into y, it's a 1. Into y here, it's a 1. We remain with a 1 over 2, which is right over here. Okay. So now from this stage, we are here. I'm running out of space, so let me clear up so that we can have some more space. We are at this point where we've got 1 to 4, 2 over y, minus 1 over a 2, and then here we have a dy. So this is what we have. We're at this stage. I've just copied, written here. And then from here, we can of course say equal to, now the integral over this 2 over 1, it will be 2 ln y, okay? Minus the integral of 1 over 2 with respect to y, it will just be 1 over 2y. And then the limits, we've got a 1 here as a lower limit and a 4 as the upper limit. We substitute the limits, it will be 2 ln 4 minus 1 over 2 and the 4 there, okay? So I'm just plugging, we get this 4, put it where y is, here and here. Then come and say minus. The same thing here, we write now this time around a 1, where y is. So that's how we deal with, or this is what we do with limits. So here we simplify, I've got 2 ln 4 minus 2 into 2, 1, into 4, it's a 2. So minus 2 Then here we've got a 0 because ln 1 will give us a 0. 0 times 2, it's a 0 minus 1 over a 2, like that. Okay? So we clean up again. We're at this stage. So let's copy equal to 2 ln 4 minus a 2. So from this stage, this will be plus 1 over 2. Because negative and negative give us a positive, we shall remain with this. So this is what we have right here. Or we can even remove the brackets, it's fine. So we simplify further. This is what we have, 2 ln 4. We find the lowest common denominator, which is a 2. This is giving us a 4 plus a 1, okay? And finally, our answer will be equal to a 3 minus 3 there over a 2. So this is our answer, 2 ln 4 minus 3 over a 2. Thank you so much for watching. Please remember to share the video, subscribe. This has been Sichamba Jacob, and bye-bye.